Hello friends, let us now learn some important points about the moving grids. Moving grids are mainly invented by Dr. Hollis E. Potter in 1920, and for many years these moving grids are called as Potter-Bucky grids. In recent years the name Bucky has been removed, the name Potter has been removed, and these are called as Bucky grids. So here in the moving grids, the grids are moved to blur out the shadows cast by the lead strips. So this is the grids and this is the X-ray tube. This is the primary radiation. So there are some shadows which are cast by these lead strips. So the grids are mainly this. Normally, the grids cast shadows due to some empty space where the radiation does not pass. So grids are moved mainly to blur out the shadows cast by the lead strips. So most moving grids are reciprocating, which means that they move continuously 1 to 3 centimeters back and forth throughout the exposure, like a pendulum. They start moving when the X-ray tube anode begins to rotate. When the X-ray tube anode begins to rotate, they move. They move from one direction to another direction. So initially, when the X-ray tube anode begins to rotate, they start to move. Older grids move only in one direction. That means after one direction, you have to bring it back to the original position. So after one direction, it should be cocked back. The grid should be cocked back for each exposure. They also so there is single stroke. These are called as single stroke grids because the older grids can only move in one direction and must be cocked back for each exposure. They also have timers that are set for little longer than the exposure to avoid grid lines. These are single stroke grids and these are inconvenient and they are seldom used in modern equipment. Instead, we use moving grids which can move back and forth as the anode rotates. Moving grids are advantageous because they eliminate grid lines from the film. Many years ago, this was important because the lead strips are thick and they are unevenly spaced. With improving manufacturing methods, the grids are improving, so the grid lines are not as distracting. But previously, when the lead strips are thick and unevenly placed, the grid lines are distracting. So nowadays, the lead strips are thick and they are equally placed, so the grid lines are not as distracting. So some radiologists prefer stationary grids and they prefer grid lines. If you are using a moving grid and if you want to avoid the grid lines, we have to take two precautions. So precautions to be taken to overcome the grid lines include: first, grids must move fast enough to blur its lead strips. If the grid moves too slowly, you will either see the grid lines themselves, or we can also see some random density variations in the film which are as distracting as the grid lines. Second, the transverse motion of the grid should be synchronous with the pulses of the X-ray generator. So whenever the grid moves, the pulses of X-ray generator should also be present at the same time. So that means grid and the X-ray generator, both these should be coordinated with each other. So the X-ray and the grid should be focused properly and perfectly. There should be synchronicity between the transverse motion of the grid and the pulses of the X-ray generator. If the grid, if the X-ray tube is either moved laterally, or if the grid is above the focal point or below the focal point, all of these will result in grid cutoff, which we have already seen in the previous classes. Now, when this happens, the shadow of each lead strip is superimposed on the shadow of its neighbor. So each pulse produces a faint image of the lead strip. So each image will produce So if you see, these are the lead strips. So these are the shadows which are cast by different lead strips. So with each pulse, it produces a faint image of the lead strip on the film. So between the pulses, the grid will move one interspace distance so that the next grid is over the position of the preceding strip. See, between the pulses, the grid will move one interspace distance so that the next lead strip is over the position of the previous or preceding strip, and with a newer pulse these two images are superimposed. So this is the next lead strip which is in the position of its previous lead strips. So these two are superimposed, the lead strips are superimposed on each other. So even though the grid moves, the grid lines will remain distinct in this situation. So this is very important. Next, the moving grids also have several disadvantages. So the disadvantages are they are costly, subject to failure. They may vibrate the X-ray table, and they may also put a limit on the minimum exposure time because they move slowly. An even more serious disadvantage is that they can increase the patient's radiation dose. There are two reasons for increasing the patient radiation dose. Number one of which is lateral decentering. Because the grid moves 1 to 3 centimeters during the exposure, the tube is not centered directly over the center of the grid during most of the exposure. So this lateral decentering will decrease or cause loss of primary radiation. Because of increased absorption of the primary radiation, there is loss of 20% of primary radiation with high ratio grids and with shorter focusing distances. So this is one reason why the patient dose increases. The second reason or the second cause for increased patient dose is a little difficult to understand. Here for example, just take an example that this is a water or some area, so water level. So when you place some partitions between the water layer, the level of the water will raise. Here also with the grids it is almost similar. So when an X-ray, this is the X-ray tube, when there is no grid, the photons are spread uniformly. When there is no grid, the photons are spread uniformly on the film, are present uniformly on the film. Now, if you use a grid here, so with the grid, the photons, more number of photons are present because some of the space is occupied by the grid. So as a result, the level or there is number of photons per unit area is more with a grid because the grid is concentrated between the lead strips. So if you take here, there are some number of photons per unit area. Okay, the number of photons per unit area here is less when compared to number of photons per unit area when a grid is used. So when a grid is used, the number of photons per unit area is 15% darker with the stationary grid because photons are concentrated between the lead strips. So the image is darker with stationary grids here. So photons spread uniformly on the film by the moving grid. Whereas here with the stationary grid, the number of photons per unit area is more. So as a result, film is 15% darker with stationary grid. The film is 15% darker with a stationary grid because of because the photons are concentrated between the lead strips. So this is not Dan. The film is 15% darker with stationary grid. The Dan should not be there. Okay. Then the total quantity of the density on the film is same with both moving grids and the stationary grids. But the stationary grids, with stationary grids, the film is made up of many narrow voids or grid lines containing no density interspersed with black lines containing all the density. So here the quantity of density is same, but in stationary grids there are some spaces or shadow lines are seen between the image. So these grid lines are seen. So these grid lines are seen clearly in the image with stationary grids. So this is moving grids. So in moving grids you see uniform density, whereas here in stationary grids there are some grid lines are seen, that is narrow voids or grid lines are seen between the uh, density. So this is non-uniform density, but the total density is same, but with stationary grid there is non-uniform density, whereas with moving grids there is the density is uniformly spaced. So these are the two important things. Thank you.